Let's welcome the first guest speaker, Mr. Gerald Nisperos of CINNOX, to share with us a topic, system thinking and transformation. Mr. Gerald, please.
Thank you, and good morning, everyone. Thanks for being here. I'm going to be talking about system thinking and its relationship with transformation and artificial intelligence. I'll be trying to articulate it visually, so but a lot of it would be quite generalized. So let me start with I'm going to go through what is system thinking, why system thinking is useful, and how system thinking helps with transformation, which is through changes of industry needs and demands. The challenges in system thinking and how AI can improve systems and transformation, and also how CINNOX has adopted system thinking to deal with transformation and AI, and the goals of CINNOX. So let me start with what is system thinking. So it's a process of understanding how parts in a system work together as a whole. And you would begin by dealing with a system. So a system could be anything from enterprise, hardware, software, communication. It's quite generalized. But a system could be both an organization and also hardware, software systems, operating systems. So a system would deal with input and output going through. So the input would go into the system and produce an output. Usually within the system there would be processes. The processes would produce the output from going through whatever the features are within the system. So there could be multiple inputs and multiple outputs within the system. So going in from a 3-input, 3-output system, within the system you can see that the top input goes into one area, but you can see process A and B are connected, but C is separated, and so is D and E. So what happens is that the input and output of the system, they're isolated. So I'll get to why this is important later, but when you have a system that has isolated inputs and outputs, the processes inside can't share any feedback or data, because there could be valuable information or insights from process B that could affect another output. But because the systems are isolated, these insights will never connect and share the same data. So from here, we're using color codes. It shows that there are 3 isolated input and output pathways within this system. So the inputs and outputs won't link. They won't meet and match. These are isolated pathways. So in system thinking, we're talking about how it's holistic, and if you use system thinking, it could help you understand a system, and if you can understand a system and how every part of the system interlinks, you can make improvements more easily, and you can control the system. So, for example, in this process, if you could combine process A and process B with process C, you can link the inputs and outputs so there's a relationship, and then link it further. And if all processes within the system as a whole have inputs and outputs, you can accommodate more inputs of a different type that you can't if you don't connect the internal processes within a system, and also produce more outputs. So with system thinking, you're seeing the system as a whole, but also connecting all of the internal processes inside, so you can then have more inputs and outputs in a closed system. So you can also have a feedback mechanism once you add more internal components and connect the processes together. So how does system thinking help with transformation? So transformation would be, system thinking would help make a system easier to update and control during times of transformation. Transformation can come about from new changes in the industries. It can come about from new technologies, new demands in the market. So if you know the system as a whole and you understand the system as a whole, it'll be easier to make small adjustments based on what the system needs to input and output. So going through time, the transformation needs of a system, let's say there's a 3-process system with 3 inputs and outputs. You can add more processes over time because the market would require more specific inputs and outputs and more processes with feedback mechanisms. And then there'll be even more need for inputs and outputs within a system with more processes inside it. Let me go. So what are the challenges of system thinking? A system starts to become more difficult to understand as more processes and interlinks and parts make it more complex. So, for example, if you have a system with several processes inside it, and then you add more processes, some of these processes may start creating isolated links again, so they won't be linked, so the inputs and outputs would no longer be part of the whole. They'd be isolated. And then the more complicated the system gets, the more isolated certain processes become as well, creating more inputs and outputs that can't be linked to the rest of the system. So this is where AI comes in. So when systems become more complex because of more processes, AI is designed to handle more complex systems. So it can significantly improve a system and make it easier to control. So for example, I'll start with trying to describe a basic neural network. So we have an input, we have layers, and we have outputs within the system. So there are technically only 2 pathways that you can take to get from one input to one output. So from these 2 pathways, let's add more neurons. Those are the white bits in between, and we've got 5 pathways now. So I'm trying to show how quickly a system can become complicated just from a few added variables. So this has 5 pathways, and now if we add 2 more inputs, 2 more outputs, we have 45 pathways now. So every addition starts to make the system more complex within this generalized neural network. Now if we add 2 more layers, plus which are 10 more neurons, we immediately have 1,125 pathways, which is quite a high level of complexity compared to having lesser nodes. And the patterns are more complex. So you can imagine certain neural networks like ChatGPT would have a huge amount more layers and a huge amount more inputs and outputs to get to these pathways. So if we generalize the AI, we'll call this an AI process to combine with other processes. An AI process can handle more complexities like pattern recognition and more accurate predictions and improved personalization from input data. So you can see generally a normal process without AI, and then adding AI processes within the system to interlink could bring in more, dealing with more inputs and more outputs. So going to CINNOX now, and why this applies to CINNOX. So CINNOX has used system thinking and AI to help it through different stages of transformation. So CINNOX generally is an enterprise communication platform. And it initially started as a global telco company. So that was the basis. And the telco company had a low latency, high speeds, and regional compliance. So connectivity was available globally through toll-free numbers and other telco connections. After that, CINNOX then added a customer experience layer, an application layer. And this consolidated more communications and put everything on a single dashboard to be interacted with. And then an omni-channel feature was added, and this allows CINNOX to transmit all forms of routing of communication, from video chats to SMS, voice calls, email, even web channels, and instant messaging. So all going into the system. And then integrations were added, so this can output information to different platforms, whether they're billing systems, whether they're project management systems, or even any other piece of software. But the capability to integrate the output of CINNOX's system with different pieces of software, popular software, allows a framework for new integrations. So if a new piece of software comes out, CINNOX will be able to adapt an integration to meet the demand in that area. And then more recently, artificial intelligence has been added to CINNOX to create a full system suite in communications. So bringing this together, CINNOX is able to handle multiple inputs and multiple outputs as a system. So this is how CINNOX has been able to deal with transformation. So CINNOX has been around for, the company has been working since 2007, starting with its telecommunication routes and its inputs and outputs from 2007. But then as time goes by, demands from the industry change, there's transformation happening within the industry. So CINNOX adjusted to add a platform as a service. So you can see that there's a change in the type of data that's being communicated. Initially, as a telco, it's just data being sent around globally. But then as a platform, messages are being sent. And then by 2015, there's a contact center as a service shift in the platform. So now enterprise insights are being communicated across the platform. And in 2020, artificial intelligence was added, which allows the system to communicate customer engagements and decision-making. So this shows how a system can change over different demands based on the industry, based on the technology. So to put it into an abstract perspective, with CINNOX, the goal of CINNOX generally through communications is to convert chaos into clarity, whether it's at different times. So just to put it into context, data is chaos and information is clarity in the sense. So if data was broken down to its raw essence, it would be time, space, energy, and matter. And these would become things like positions, identities at the time. But to turn this chaotic data into information, initially, from the telco, signals would be the first things being sent. And then messages would be counted as that information. And then insights. And now with AI involved, decisions are the form of clarity that everyone wants from within the system. So to summarize the review, system thinking is an approach of looking at a system as a whole with all of its processes and interlinks inside. System thinking can help enterprises adapt and adjust through times of transformation where there's shifts in the industry and technology. Artificial intelligence helps a system track patterns, predict behaviors, and adapt as a system becomes more complex. And then CINNOX has adapted all three of these. They've sat through 15 years of transformation and adapted using system thinking. And they've started to harness the power of AI for their enterprise customers and their customers. And finally, CINNOX has an underlying philosophy to turn chaos into clarity. Thank you for listening.
Thank you, Gerald. Please take your seat.